Okay, guys, we're going to look at problem 12-141 in the 12th edition. Okay, in the 12th edition. Here we have a truck that's going around a bend. Okay, and what's happening? What's happening here? It says the truck travels along a circular road that has a radius of 50 meters. Okay, so circular means we're looking at curvilinear motion. It has a radius of 50 at a speed of 4 meters per second. Okay, so this truck is moving in a curved motion and it's going at 4 meters per second. Then it says for a short distance, when t equals 0, its speed is then increased. It was going at 4, it's now increased by this. At is 0.4 t. Okay, determine the speed and the magnitude of the truck's acceleration when t equals 4 seconds. Okay, so this is 1241 in the 12th edition. Okay, so let's have a look at this problem. Okay, so we've got curvilinear motion. Okay, so we should just set up this problem. We know we're going to, perhaps the best way to deal with this is using our normal and tangential components. Okay, let's put that there. Okay. We know that the velocity at the beginning is 4 meters per second. We know that our radius, this is the radius of curvature, our radius is 50 meters. Okay, and at time equals 0, right? We're basically starting the clock, essentially. Our acceleration, and notice it's t. What does that mean? It is our tangential acceleration, is given by 0.4 t meters per second squared. Okay, so that's our information. And we want to know, what is the question? The question is, what is the speed at t equals 4 seconds, and what is the magnitude of acceleration at t equals 4 seconds. Okay, so there's our two questions. There are our two questions. Okay, so we know it's a normal and tangential coordinate problem, component problem. We know what our v is, rho, at. The first question is, what is our speed at t equals 4 seconds? So we know that our at is dv dt. This is, we're answering question 1 now. Okay, and our at is 0.4 t. We separate variables and we integrate. We're going to have dv is the integral of a 0.4 t dt. Now I want to ask you, what are my limits over here? What are my limits? Remember, this car, the truck is going here, and at this point it was going at 4 meters per second, right? At that point when we started. But then it began to accelerate, right? With this, acceleration equals 0.4 t. So can we see that our initial velocity here is 4, and our final velocity is v here. Those are our limits. Okay, so it starts at 4 meters per second and then it begins to accelerate, and we want to find that velocity at t equals 4 seconds. This is going to be between 0 and t. So we're going to have here v minus 4 equals, and if you do the integral here, you should get 0.2 t squared. All right, so we have v is 0.2 t squared plus 4. That's our equation. Okay, so it essentially starts at 4 meters per second. That's the initial velocity, and then it begins to accelerate. It accelerates with this, right? So that's our initial component. Okay, so at t equals 4 seconds, v equals, if you plug that in, you're going to get 7.2 meters per second. Okay, so I hope that makes sense. We're initially going at 4 meters per second, okay, and then we begin to accelerate at 0.4 t. So what do we need to do? We need to integrate this with respect to time, and we get this equation. But don't forget that we needed to put in our initial velocity there of 4, okay? And then we end up with this. Okay, so that actually is pretty straightforward. Nothing new there. But now the second question is, what is the magnitude of the acceleration? What is the magnitude of the acceleration? Where are we going? Our acceleration with normal and tangential components looks like this. AT ut plus v squared over rho un. Right, that is our acceleration, and we want the magnitude of this acceleration. Magnitude of the acceleration at t equals 4 seconds. So we know that AT is given by that, okay? And we know V is given by this. That's at 4 seconds, by the way, okay? We know that that is the velocity at 4 seconds, so we've got this. And we know that rho is 50. So our acceleration, the magnitude of the acceleration, is then our AT squared plus V squared over rho squared. By the way, I just want to point something out here. When you're calculating the magnitude here, just take note that it's V squared over rho and that whole thing squared. I think perhaps sometimes you might get confused and say V squared over rho, oh, I've already squared this, okay? But no, the component is V squared over rho, and you need to square that, right? Okay, and then we square root. So what is AT? AT is, we know that AT was given by 0.4 t, okay? And we know that t equals 4 seconds, so it's 0.4 times 4. Now that whole thing needs to be squared. And then we get, what is V? At t equals 4 seconds, it's 7.2 squared divided by 50, because your radius of curvature is 50 meters. Now this whole thing needs to still be squared, and this whole thing needs to be rooted. All right? So now the magnitude is, just hold on 1 second, should be 1.91 meters per second squared. Okay, so this is a pretty straightforward example, but hopefully doing these basic examples, you're starting to get the hang of it. Okay, cheers.